you equivalent of 4,500 cars. The Pont Jacques Chaban-Delmas is the tallest lift bridge in Europe. It spans almost 600 meters and has a central lifting section of almost 120 meters in length. The 2,500 portion of the bridge is the equivalent of about 1,500 cars in mass. It's very heavy. The 77-meter tall piers on either side of the bridge allow that 2,500-ton portion to be lifted almost 60 meters high.
How does the bridge lift this heavy middle section? By using a counterweight and extra assistance.
The central section of the bridge can be raised and lowered thanks to machinery located in the four
Leave.
pilings. Each of these pilings has a counterweight of 600 tons, and electric motors are located underneath the bridge, allowing the bridge to raise and lower the roadway with ease.
If we don't use counterweights, the motors would have
Four and
to be
30.
the 2,500-ton bridge. That's a lot.
4 and 30.
Motors large enough to do that. The counterweights offset the
Leave.
bridge and allow the motors to move a much smaller load. The bridge
Leather pause.
but equally colossal was the construction process.
Welcome to leave shots.
Construction on the bridge started in 2009. The bridge was assembled from massive sections weighing up to 6,000 tons that were constructed off-site, floated into position, and meticulously and precisely assembled. Several sections of the bridge were floated in on barges. One of the most interesting parts of its construction was the base, constructed from steel and concrete, were actually floated in on their own.
But how did engineers make these massive structures of concrete and steel float?
Archimedes' principle says that an object will displace the same amount of water as its weight.
So if we build hollow structures, even with very heavy building materials, we can make them float. So historically, we've actually built large river barges and other vessels with concrete. You can actually find concrete ships and boats having been constructed. That kind of engineering technology was used in this bridge, in that each of the modular sections that forms the pier was made to be hollow so it could be floated into position and then sunk where it was needed.
That's not to say that floating these in was easy. It took a team of 4 days and 4 nights to float them into position.
Leave. Welcome to leave shots.
I've always wanted to say thank you.
Thank you.
Thank you for saving my life.
Because of your mad hopes, dreams, like it means everything.
If it wasn't for you, we wouldn't be here.
Who are they supposed to search for?
Welcome to leave shots.
Ei ole väliä, onko se esille otettu tai esipesty tai käytetty nopeaa ohjelmaa, mutta mikä todella on tärkeää, on se, että käytät vain 30 minuutin ihmettä. 5 onnistustielimme yhdistetty voima. Vairi 30 minuutin ihme selviytyy jopa vaikeista ruokaongelmista. Se on todella tärkeää. Vairi 30 minuutin ihme, meidän ykkönen vaikeiden ruokapuhdistusten hoidossa. Täysin
Hi.
täyssähkö. Mazda CX-6e. Ensiesittelyssä syyskuussa.
How are you? Hi.
Ei voi tie.
Suomen suosittu autovakuutus korvaa arvaamattomat ja arvattavat vahingot. Mitä enemmän vakuutat, sitä enemmän säästät. Saman tien. Lähitapeilla.
Now here's something you didn't realize till just now. You'll probably overpay for your hotel. Unless, of course, you check Trivago. On Trivago, you can compare prices from multiple sites in one place, so you can save up to 35%.
Suomalainen arki vaatii energiaa. Hele, siinä on energiaa.
Pastilli kuin filter. Maista uusi Jenkki Switcher. Se nyt oli pastilli. Anna kymmensi loistaa.
Jos mä saisin valita, mulla olisi jopa lääkkeitä.
Welcome to leave shots.
Hae asuntolainaa osuuspankista, niin olet askeleen lähempänä unelmaa.
saumakotia, sijoitusasuntoa tai mökkiä? Tiesithän, että asuntolainasta kertyy omistaja-asiakkaalle
Marokko hurmaa jokaisen naisen. Värikkäiltä kattoterasteilta, eloisille kujille, katumaisista riakoista useisiin modelleihin. Varautusko
edullisin kampanjahinnoin. Kun mäkkihimo iskee, me olemme valmiina. Maista maidin jalapeeno. Myös tuplana. Mäkkäristä.
Maailmankas uutuus. Täydellinen ruuva. Pehmeää marabu-maitosuklaa kohtaa rapean pistopuun. Koe vastustamaton makuelämys. Marabu-pisto. Marabu.
To attach those piers to the river bottom, caissons were driven down into the ground and then filled with concrete themselves.
Welcome to leave shots.
construction on the towers could begin. The construction of the four towers was extremely interesting. Sections of these towers were transported to site and were individually placed on top of each other, like building blocks, until they
Migan Masi.
This entire bridge
Hello.
in a modular manner.
piece by piece, over a 4-year period, this bridge came together. Each piece had its own challenges and required precision, but the centerpiece might have been the most challenging.
Positioning of this central portion was very difficult because there was only a few centimeters of clearance between the pylons to position it correctly.
The placement was successful, and met in the middle to celebrate a job well done.
Once the central span was in position, the only thing left to do was to put a layer of asphalt on the bridge, and the bridge opened to the public in 2013.
With great fanfare, dignitaries and citizens turned out to commemorate the colossal achievement.
When I see this bridges like this in action as an engineer, I'm like, wow, this is really amazing. We're moving a huge amount of mass and extremely high distance up in the air. It's almost unbelievable to see structures this large move.
Not only does this vertical lift bridge function, it's also striking to look at and blends beautifully with the Bordeaux aesthetic. Each of the towers has multiple walls made from glass with lights inside. This makes the bridge both visually striking and able to be used for nighttime light shows. While the Paul-Jacques Chaban-Delmas Bridge bridges a city, this next colossal machine has the potential to bridge a 19th century technology into the 21st century.
Trains are an exceptionally efficient way to move goods because we can put a huge amount of material behind one locomotive and pull it vast distances.
In a typical year, 1.54 billion tons of freight is moved across the continental United States. The European Union sees well over 300 billion ton-kilometers of freight every year.
The way we move material on trains is measured in ton kilometers. So this is the amount of weight moved through 1 kilometer. So if you have a train that weighs 100 tons and you move it 1 kilometer, you'd have 100 ton kilometers. In the European Union, every year, there's 300 billion ton kilometers of freight moved through.
Welcome to leave shots. Welcome to leave shots.
Represented a prime method of land travel for passengers and cargo from the 1800s until well into the 20th century. By the 1960s, steam engines had largely been phased out in America. With the importance of trains to transportation, commerce, and freight, people are looking to find advancements in rail travel.
Any improvements in efficiency will decrease the train's environmental footprint and decrease the cost to transport the goods.
Steam engines were replaced by the more efficient internal combustion. Internal combustion engines had many advantages over steam. Internal combustion engines are more efficient and can produce more power, while being slower than steam engines.
Internal combustion creates great power to haul heavy loads, but
were launched in the 1920s, which allowed trains to shut down their diesel engines when operating on a third rail or under wire.
There's two different types of propulsion within trains. You can have diesel electric, where we have a diesel motor that runs a generator that in turn powers an electric motor that then moves the train. Or you can have a fully electrified train where we forego the diesel motor and generator and power the train directly off the electrical grid. To power the train off the electrical grid, we use a third rail, which may be located below the train, between the tracks, or adjacent to the tracks. And then electrical contact between the train and the third rail provides the power to the motor in the train, which propels it forward. Additionally, you could have an overhead wire system, which uses a pantograph, which is a type of mechanism that keeps a contact on the top of the train in contact with the wires above to provide the power to
Can only happen in the field. Battery power can offer an improvement over these systems.
Battery-powered vehicles are becoming more common, but this technology hasn't been yet. This wouldn't power your sedan or even a semi-truck with batteries, but when you're looking at hauling hundreds of tons,
These batteries have a power output of 2.4 megawatt hours.
A megawatt is an immense amount of energy, so this is enough to power several hundred homes for a day that's going into this train. It's not a small amount of energy. And that energy can be used by the train to generate 2,400 horsepower of power to move that train forward, and it can get the train up to about 120 kilometers an hour. So this is a really amazing system that allows us to move from relying on diesel engines to spraying power.
Batteries in themselves
Welcome to leave chat. Welcome
Charge the battery, the lithium ions move off of the anode into the electrolyte and over to the cathode. There are some discharges of batteries. Lithium-ion batteries are really great because they hold an immense amount of charge. They have a high charge density. And also, lithium-ion batteries don't have a memory. They have really low. And also, lithium-ion batteries don't have a memory. They have a really low rate of self-discharge. They're really ideal for many, many applications, which is why we use them in cell phones and so many other devices. With respect to the WABTEC system, this is really beneficial because it allows you to have a really, really simple system that can provide a lot of energy when needed.
With thousands of kilometers of track, the battery-powered locomotive could still run into trouble. If it lost power far from a recharging station. But the WABTEC engineers added an innovative feature to recharge on route.
so much energy in our modern engines is lost to heat. Enough heat energy using radiators instead of putting that heat energy to use.
We have a moving object. It has kinetic energy. It has a lot of energy associated with motion. And when we slow down using our brakes, we convert that immense amount of kinetic energy into heat energy brakes, and it's wasted. We're just basically heating up air around the car. The same thing's happening in trains. The next thing about the WABTEC system is it uses regenerative locomotive. That way we're saving and reusing all of that kinetic energy and reducing the overall input to the system, make it more efficient.
Basically, you're taking all that heat and friction and using it to charge batteries as you're depleting them. It's a constant cycle of recharging your batteries.
California, Barstow, and stuff.
That might not seem like a lot, but on a typical 1,000 kilometers, that translates to savings of over 23,000 liters of fuel, or 62 tons of greenhouse gas emissions.
After successful test runs with the prototype, WABTEC engineers are building a more powerful, upgraded engine.
The second generation of electron is 3 times the
The batteries of the second generation WABTEC flex drive are truly enormous, requiring a crane in order to remove them. Those batteries allow the WABTEC flex drive to have a power output of 7.2 megawatt hours. That's over triple the prototype. resulting in a potential power output exceeding conventional diesel-electric locomotive.
This generation engine will be commercially available in 2023.
Commercially available battery-powered trains can be a game changer for the industry.
The 300 billion ton kilometers of goods transported in Europe every year is a huge amount of material. The WABTEC system reduces the environmental impact of that by increasing the efficiency of how we transport those goods.
The WABTEC Flex Drive is quite simply an electric train, but it allows us to reduce our dependency on fossil fuels for the transport of goods in huge amounts over long distances.
This is the future of rail freight and trains across the globe. The FlexDrive engines have already been procured by CN Rail in Canada for usage, as well as in Australia for an iron ore mining operation. In the Australian iron ore mining operation, the FlexDrive is 35,000 tons of iron in 55 degrees weather.
With colossal batteries, reduced emissions, and a huge hauling capacity, WABTEC's FLX Drive is a modern marvel in the cutting edge of rail technology. But sometimes, you need a massive transport that doesn't ride the rails, but hovers just above the surface.
Fennia. Fennia.
Saat se kaiken tehtyä?
Joo, ja ihan kohta me ollaan kotona.
Me ei jääkään vielä.
Yhteisellä matkalla. What a hotel, right? And only 210 a night on my favorite site. What? You didn't check Trivago. I got mine for 140. You have to check Trivago. Oh yeah? Prove it. On Trivago, you can compare hotel prices from multiple different sites. See? Same hotel, 70 euros less. You didn't check Trivago? I didn't check Trivago.
Vertaa hintoja Trivagossa ja säästä jopa 35%. Hotelli Trivago.
Miksi sä kokeilla Tinderia? Se löytyy varmaan sieltä.
Pienetkin tavarat voivat kyllä ehdottaa paljon. Nyt kodintavaroita, muotia, kirjoja ja paljon muuta missä ilman muuttikuuluja. Eikä löydy käyttöä. Minä uskon Viraattoria. Siinä on todennäköisesti erittäin laadukkaita aineita talosta mutta myös niiden aineiden vaikutuksista. Et se on hyvä koostumus ja sen takia mä aloitan siihen. Pro antaa tukea lapsille ja nivelille, jotta sinullakin voisi olla vähemmän. Aloita tilasta alle 10. Loppuun asti.
Tuu kohta takas. Hieno Rekku. Istu. Moi. Nyt mennään kotiin. Rekku. Aika. Rekku. Mitä sä teet? Rekku. Lopeta heti. Ota ihan sekasi, Rekku. Tuu mua kuilo. Sori. Mihin me jäätiinkään? Red Bull antaa sinne.
I'm Dad Sir. And I'm Professor Suzanne Lipscomb. And together we're investigating the world of the shoes in a whole new way.
died? A modern investigation.
Uncovering fresh evidence.
Best way to make a friend.
Mikä tekee kuninkaan? Iopettu saa pian tietää.
Happy,
Tässä vaan
happy birthday to you. Happy birthday to you. Happy birthday to you. Happy birthday to you.
The ocean is a pretty unpredictable thing, and often we think about these idyllic places where you land, you have a dock, and you can easily disembark your vehicle. But there are so much coastal area in the world.
Moving people, supplies, and equipment from ship to shore can be a challenge. When you're trying to land on beaches without a dock, things can become more risky. At some of the largest payloads on the planet, and moving from ship to shore can be deadly.
Due to their terrain, shoreline landings are some of the most challenging military operations to undertake. This can be seen at Omaha Beach on D-Day.
In World War II, coastal assaults and military landings were conducted by amphibious landing boats. Troops and equipment had to rush up the beach, often struggling through heavy waves and surf to land on the coast.
Shorelines are extremely complex environments. There's the terrain itself, but then there's also wind, there's waves, and there's tides that then make the environment even more unforgiving.
Throughout history, transport from ship to the coast forced smaller boats and crews to struggle through the surf and hard terrain, which caused loss of goods and lives.
Historically, when we look at trying to land equipment and people on beaches, we use boats. Boats aren't very efficient at getting to shore. Boats travel relatively slowly, 11 knots, 22 kilometers an hour, really not high speed. And then when they get to shore, you have to have really complicated landing systems to make sure you can discharge troops or equipment onto shore relatively easily. And even then, only about 17% of the shoreline would be accessible to these types of vehicles.
After World War II, the military began using more helicopters to deliver goods to shore. Helicopters provided the capability to launch over the horizon amphibious assaults, which offered a military advantage in surprise without any fire. But there's a downside to helicopters too.
Helicopters really can't carry heavy loads. They're very exposed in terms of warfare. They're easy to shoot down. They're also very, very prone to wind and weather conditions, so it makes them very difficult to use in a maritime environment. So we really needed another system to move goods from ships or troops from ships to shore. The hovercraft is a great solution.
One of the models demonstrated the ability of hovercraft to operate over land. The ramp is twice as high as the hover height of the model, yet the bottom did not touch the ground, and any heaving and pitching was quickly damped.
The first practical design for hovercraft was derived from British inventor Christopher Cockerell.
It was the beginning of a great project to provide a craft which could travel over water, however shallow.
In the 1950s, Cockerell, with funding from the British government, created the SR-N1 hovercraft. In 1959, the SR-N1 successfully crossed the English Channel and proved the viability of hovercraft in maritime operations. And then, in 1985, the U.S. Navy launched the first LCAC, or Landing Craft Air Cushion.
The LCAC
Welcome to Live Charts.
it allows access to about 80%
Welcome to Live Charts.
Hovercraft can travel directly from the ocean to the land. They're relatively high speed. And when you do get to shore, it's really easy to discharge your equipment and people.
The LCAC was so successful that the military put over 90 of these vessels into service. But as cargo and equipment needs continued to increase, it was obvious that a stronger, upgraded LCAC was needed to handle the colossal weight of armored vehicles and tactical equipment.
In 2010, the U.S. Navy commissioned an upgraded version of their LCAC. connection. The SSE is a marvel of engineering. It can travel in the well deck of a ship, allowing the craft to remain sheltered from weather, waves, and the enemy during transportation and loading of the craft. This upgraded ship can carry 65 tons of payload. For me, what's stunning is to see this enormous machine that I know is just hovering on a small layer of air, that it's actually not touching the ground.
It really is magical. It's quite a miraculous thing to see it operating and transitioning from choppy ocean onto the shore in ease.
The LCAC and SSC are supported on an inflated skirt. This skirt, known as a bag and finger system, supports the weight of the craft on a cushion of air. That cushion of air is enough to support 173 tons, which includes both the weight of the vessel and the full payload.
This thing is huge. It can haul a tank.
Over 170 tons floating on air. How is that even possible?
Hovercraft work on the principle that we can use pressure to support heavy loads. Basically, if we have a large surface area with a seal below it, which in the case of a hovercraft consists of a skirt and a finger system that basically seal the deck of the hovercraft to the surface below it, whether it be land or ocean, we can build pressure under that skirt, and if we build enough pressure, that pressure will support and push up. That causes the craft to lift up and hover off to the surface. That really is an amazing thing because in these vehicles you can lift up to 170 tons. This is a massive amount that can put hundreds of people or an Abrams tank on the deck of these hovercraft. And then because it's floating nearly frictionless over the surface it's riding on, it can achieve really high speed.
Hovering over land and sea, the SSC can operate full loaded at speeds of up to 74 kilometers per hour and has an effective range of over 50 nautical miles or 93 kilometers. This allows the SSC to facilitate amphibious assaults from OTH or over the horizon, meaning naval vessels can stay well out of the reach of enemy fire while launching forces.
In order for the SSC to move 60-ton payloads at high speeds, it needs very powerful engines. The SSC has 4 Rolls-Royce MT7 gas turbines capable of sustaining up to 16,000 horsepower each. For perspective,